Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Before we proceed, I'd like to kindly appreciate our new members and also request more to join the group so that we can form a large community of members who are studying these various topics in sciences and mathematics. Now, in this particular case, I'm going to look at the concept of halogens, and these are going to form a unique group of the periodic table, which we are going to see having a diverse range of especially reactions. And of course, we're going to see that in comparison with other non-metals of the periodic table, this is going to form relatively highly reactive members of the periodic table, especially on the concept of non-metals. And I'm going to give specific examples and detailed form, perhaps in forms of reactions, as we're going to proceed with our discussion. In this particular case, I'm going to look at this specific group. And as I had said, of course, these are going to be given in terms of the group 7 members, or group 7 given as such. And this is going to be, now in our last discussion, I basically mentioned the concept of IUPAC naming of these specific elements of the periodic table. And I'd said that particularly metals are going to be assuming a characteristic services which are going to be given in terms of EM, and this basically is going to be giving a specific meaning as per our last explanation. Now in this case as well, we're going to consider the concept of IUPAC naming system of these particular elements. But in case we come a specific designation from various texts which we are going to use in our studies, perhaps trying to illustrate them as group 7, Roman 7 given as such A, and this one which has got a numerical figure together with an alphabetical letter, then therefore it's going to imply the same. And also we're going to see that if we try to consider the concept of transitional elements, these are going to be still designated as a group 17. And of course this is going to be taking account of course, these specific elements ranging from group 13 to 12, which we had said basically the inner and outer transitional elements. Now in this case, these are going to form a class of what we refer to as halogens, and these halogens are going to display a range of characteristics which I have said, among which we are going to look at, of course, I've mentioned one, which is basically they're going to be relatively reactive as compared to other non-metallic elements, and of course therefore they are going to be the most reactive group of non-metallic elements, which I refer to as halogen. That's going to be one of their characteristics, and we're going to see that they are going to be displaying this sense of being volatile, which means they're going to be susceptible to evaporation. And basically we're going to see that we're going to have these ones classified. Now apart from these ones being non-metals, we're going to see that they are going to vary in their physical characteristic, in a sense that fluorine and chlorine, being members of these groups, are going to be gaseous states, or gaseous at room temperature. And then we're going to see that bromine is going to be a volatile liquid, and iodine is going to be a solid, of course, which we said in one of our videos that is going to display one of the unique characteristics of sublimation. Therefore, this is going to be a solid which can be easily sublimed, and of course these are going to be some of their physical properties. Now in this case, I mentioned the members of fluorine, chlorine, bromine, and iodine, but as well we're going to see that there are some additional members that we're going to see in a periodic table which constitute this specific element that is referred to as astatine, and this is going to be forming a member, of course, directly below this specific member which we refer to as iodine. And then next we are going to talk about this particular member, which is referred to as tennessine, and of course it's going to be at the lowest part of this range of elements that we refer to as halogens. Now in this specific case, it's going to be more elaborate for us when I'm going to use an illustration of the periodic table. but in case, of course, in order of the ascending order from the first, of course, period to the last one, we're going to see that it's going to be, of course, going in this specific order from fluorine, chlorine, bromine, iodine, astatine, and lastly, tungsten, given in that particular case. Now, apart from being highly volatile, of course, we have seen that some members are gaseous in their physical formation. Like bromine is going to be a liquid, whereas iodine is going to be a sublimable solid, or a solid which can be sublimed given as such. Now, these are going to form what we refer to as a strong oxidizing agents. And of course, in order for us to understand the concept of oxidizing agents, we say that basically these are going to be agents which are going to readily pull electrons from other atoms. And in case we perhaps we can give that one in form of an equation form, but that's going to be, of course, in our later discussion. So these are going to be strong oxidizers, which are going to be forming this specific range of elements referred to as the halogens. And these are going to, of course, as I've said, readily pull electrons out of or from other atoms in that particular case. And next, from them being highly reactive, volatile, and strong oxidizing agents, we're going to see that they normally appear in diatomic form, which is going to be given in terms of this specific general representation. And of course, they are going to form, of course, molecules of this specific nature over X sub 2, which I've given on the board. And additionally, they are going to form ions of charge -1, which is going to be given as such. Of course, they require one electron in order to obtain the octet state, and therefore they're going to form ions of -1 given as such. Now, there are various range of applications of these group 7 elements, or group 17 elements, and some of them are going to be, of course, being shown in their compounds, but we can identify one like chlorine, which is basically used in water treatment. And there are various ranges of other applications which we are going to see, especially in formation of other chemicals, as I've said, which are going to be especially exploiting the compounds of the various range of these halogens, of course, which are group 7 elements. Now, these are some of the characteristics which we are going to witness, and as we go by, of course, in analyzing each and every element in this particular case, we shall have additional applications which we are going to see under some of the physical and chemical properties being added to what we have just discussed in a general way. Now, that is it for now, guys. I'd like to perhaps give just an overview of the various elements which we are going to come across, and this is going to be an illustration of a periodic table which I'm going to show this specific group of elements. Now, above is a display of the entire arrangement of the periodic table. I presume that we are going to be, it's going to be feasible for us. Probably the symbols which I've given for various representations of members of the group or the period of this specific, of course, classification. In this case, this is going to constitute the alkali earth metals, and these are going to constitute the alkaline earth metals given in that particular order. And the range of of course, elements in this specific central part is going to constitute transitional elements together with this lanthanide and actinide series given as such. Now, the lower, at the far right side, we're going to have the second last column, which is consisting of elements denoted in yellow coloration. And these are going to be the fluorine, chlorine, bromine, iodine, astatine, and tungsten. And these basically are going to be forming our set of what we refer to as halogens. Now, in this case, they are going to constitute a specific way of perhaps a designation for this IUPAC naming system, and the general one which we are going to come across in a variety of literature. And of course, they are going to refer to the same group of elements. Now, in this case, I'd like to encourage our members to kindly check our description boxes for various links of other videos, and also subscribe to our channel so that we can be having a healthy discussion on various topics under the comparative study of S&P block elements. So that is it for now, guys. Bye, God bless you. Catch us in our next video.